Attention, please. The international conference is about to begin. To all participants, please turn off your microphone. Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
In the name of Allah, the most gracious, the most merciful. The Honorable, the keynote speaker, Bapak Profesor Dr. Heris Hendriana MPD, Chairman of Indonesian Mathematics Educator Society or IMES, Bandung, Indonesia. The Honorable, the invited speakers, Professor Gyongaiver Molnar, DSc PhD, from Institute of Education and Deputy Head of the Doctoral School of Education, University of Zagreb, Hungary. The Honorable Professor Dr. Ahmad Fauzi bin Mohayu, from Faculty of Educational Studies, University Putra, Malaysia. And the Honorable Professor Dr. Budi Murtiasa MCom, from Universitas Muhammadiyah Surakarta, Indonesia. The Honorable Rector of Universitas Muhammadiyah Surakarta, Bapak Profesor Dr. Sofyan Anif MSI. The Honorable Vice Rector of Universitas Muhammadiyah Surakarta, Bapak Profesor Dr. Harun Joko Praitno M.Hum. The Honorable Vice Rector of Universitas Muhammadiyah Surakarta, the Honorable Bapak Profesor Dr. Muhammad Dai MSI APT. The Honorable the Head of the International Conference on Mathematics and Learning Research, Bapak Adi Nur Cahyo SPD MPD, and the audience. Praise be to Allah Subhanahu wa Ta'ala, the cherisher and sustainer of the world. Salawat and salam may everlastingly be upon our adoration, Rasulullah Sallallahu Alaihi Wasallam, who had guided us from the darkness into the shining bright path. The honorable audience and distinguished guest, I am Belva Amalia Desati as the Master of Ceremony today. Welcome to the International Conference on Mathematics and Learning Research on Wednesday, September the 14th, 2022. Let's start this event by reciting Basmalah together. Bismillahirrahmanirrahim. Ladies and gentlemen, our first agenda. Now we're going to listen to the Holy Quran recital by Zain Taufiqah with the Surah Al-Baqarah, verse 147 to 149. The Honorable Zain Taufiqah, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. الحق من ربك فلا تكونن من الممترين. ولكل وجهة هو موليها فاستبقوا الخيرات أينما تكونوا يأتي بكم الله جميعا إن الله على كل شيء قدير ومن حيث خرجت فول وجهك شطر المسجد الحرام وإنه للحق من ربك وما الله بغافل عما تعملون وإنه للحق من ربك وما الله بغافل عما تعملون صدق الله العظيم والسلام عليكم ورحمة الله وبركاته.
Thank you, Zain Taufiko. Ladies and gentlemen, it is time to carefully listen to the national anthem. To all participants, you are all advised to stand. The national anthem, Indonesia Raya and Sang Surya. Thank you. Happy audience. The upcoming session is opening remarks from the Chief Committee of the International Conference on Mathematics and Learning Research. The Honorable Bapak Adi Nur Cahyo, SPD, MPD, the floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah. Alhamdulillahirrahmanirrahim. Wassalatu wassalamu ala asrafil anbiya wal mursalin. Wa ala alihi washabihi ajmain amma ba'du. First, I would like to express my respect to the Rector of Universitas Muhammadiyah Surakarta and the Vice Rectors, the Dean and Vice Dean of the Faculty of Teacher Training and Education, Universitas Muhammadiyah Surakarta, Chairman of ISET 2022, the Heads Department at Faculty of Teacher Training and Education, Universitas Muhammadiyah Surakarta. To the experts, keynote speakers, Professor Dr. Hendriana from IKIP Siliwangi Bandung as a Chairman Indonesian Mathematics Education Society, Prof. Gyongfer Molnar from University of Szeged, Hungary, Professor Dr. Ahmad Fauzi bin Muhammad Ayub from University Putra Malaysia, and Professor Dr. Budi Murtiasa from Universitas Muhammadiyah Surakarta, Indonesia. Then, to all invited guests, presenters, participants, and committees of the Mathematics Education Department, Faculty of Teacher Training and Education, Universitas Muhammadiyah Surakarta. Dear audience, Alhamdulillah, Let us give thanks to Allah SWT who give us the healthy time and also the chance to meet in the Zoom meeting to attend ICOMER 2022. Then we ask Allah to grant salawat and salam to the Prophet of Muhammad SAW, who is waiting for his miracle in the Yaumul Qiyamah. Amin ya Rabbal Alamin. The second international conference on mathematics and learning research, ICOMER, was held by Mathematics Education Department, Universitas Muhammadiyah Surakarta, Indonesia. It is part of the International Summit on Science, Technology, and Humanity, ISET 2022, organized by Universitas Muhammadiyah Surakarta, Indonesia. Mathematics learning should be about developing conceptual understanding to prepare students for the 21st century. Successful 21st century mathematics learning needs to foster 21st skills such as computational thinking, creative, critical thinking, collaboration, communication, and compassion. Computational thinking is an approach to solving problems in a way that can be implemented with a computer and is distinct from computer science. Then mathematical thinking is a process that can be viewed through many different lenses and involves the application of mathematical skills to solve math problems, and is supported by an atmosphere of questioning, challenging, and reflecting. Therefore, conference aims to accommodate research dissemination from practitioners and researchers in the field of education with the theme of enhancing mathematical and computational thinking in digital technology era. Today, conference will be divided into two sessions, panel session and parallel sessions. At the panel session will be the presentation of the keynote speakers, Professor Dr. Hendriana, then Professor Dr. Ahmad Fauzi, then Professor Dr. Budi Murtiasa, and Professor Gongyer Molnar from Hungary. At the parallel session, we will have the presentation of accepted manuscript. In the second ICOMER 2022, we recorded there are 103 submitted manuscripts. Among them, 98 manuscripts are accepted to be presented, which consisted of 34 manuscripts from student author of the Mathematics Education Department, Universitas Muhammadiyah Surakarta, 62 manuscripts from general author, and 5 manuscripts from overseas authors. More than 20 reviewers supported this event. We also collaborate with AIP, Mathematics and Statistics Journal, Ciramat Edu, Barekeng, and Syllogisme. AIP is Corpus Indexed Proceeding, Mathematics and Statistics is Corpus Indexed Journal. Ciramat Edu and Barekeng is indexed in Sinta 2, then Syllogisme is indexed in Sinta 3. We are pleased to announce that 34 undergraduate students from Mathematics Education Department, the Faculty of Teacher Training and Education, will have the opportunity to present their final project at this conference, then publish it in the mentioned reputable proceeding. According to the policy of Universitas Muhammadiyah Surakarta, upon the successful publication in the reputable international proceeding, the examination of the final project is no longer required. We hope this opportunity will encourage the student to be graduated with excellent talents, especially in publishing their project in the future. Dear audience, this fantastic event will not be held without the contribution of all committee members. Therefore, special thanks to all committees who have dedicated their best works. Also, the reviewers who have worked hard to serve valuable suggestions for manuscript improvement. Special gratitude is delivered to the keynote speakers of this conference. Their presentation will have significant addition for all audiences. For the last, we realize some problems might occur during the conference. What can we say is we do apologize for the unpredictable inconvenience during this virtual conference. We would like to say thank you and highly appreciate your participation. Bila daya, Assalamualaikum warahmatullahi wabarakatuh.
Salam.
Thank you, Bapak Adi Nur Cahyo, SPD, MPD. Ladies and gentlemen, we're going to have another speech from Vice Rector of Universitas Muhammadiyah Surakarta, the Honorable Bapak Profesor Dr. Muhammadiyah MSI APT. The floor is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin wassalatu wassalamu ala anbiya wal mursalin wa ala alihi wa ashabi ajmain. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma salli ala Muhammad wa ala ali Muhammad. Good morning, ladies and gentlemen, and honorable speakers, Professor Dr. Haris Hendriana from IKIP Siliwangi Bandung as a chairman Indonesian Mathematics Education Society, AIMES. Honorable speakers, Professor Kyongfir Mornar from University of Szeged, Hungary. Professor Dr. Ahmad Fauzi bin Muhammad Ayub from University Putra Malaysia, and also Professor Dr. Budi Mutiasa from Universitas Muhammadiyah Surakarta, Indonesia. And to all of the participants, thank you to all of you for your attending in this event today. In this occasion, on behalf of Universitas Muhammadiyah Surakarta, I would like to express my warm welcome and my sincere appreciation to all of participants on the second ICOMER 2022 with the theme Enhancing Mathematical and Computational Thinking in Digital Technology Era. Ladies and gentlemen, first of all, I would like to give a brief description about Universitas Muhammadiyah Surakarta. Universitas Muhammadiyah Surakarta, also known as UMS, is one of 170 Muhammadiyah universities in Indonesia, owned by Muhammadiyah Islamic Organization. It was established 64 years ago. Currently, we have 12 faculties with 35 undergraduate programs, 16 master programs, 3 doctoral programs, 7 professional programs, and with 70% have attained highest level in national accreditation, which A or Unggul. Ladies and gentlemen, next 2 months, on 18 to 20 November 2022, we have the biggest event in Muhammadiyah organization. We have the 48th Muktamar Muhammadiyah and Aisyah with the topic Advancing Indonesia and Enlightening the Universe. This topic, of course, is very relevant with the spirit of Muhammadiyah that established 110 years ago to protect and to keep the weak people and to promote them in the better, including become more competitive, better welfare, with strong faith and good deed. Ladies and gentlemen, today's conference become part of important movement of Muhammadiyah and also Universitas Muhammadiyah Surakarta to promote the quality of Indonesia human resources competitiveness, not only in national level, but also in international level. Very short targets. This conference aims to promote the collaboration and the publication in mathematics fields. It's very important to promote better understanding that mathematics education is very important and mathematics education is interesting, not become a scourge to the student. Again, thank you to all the speakers and participants who joining this international conference. I sincerely hope that this event will be successful. And let me allow me to open this conference officially by recite basmalah. Let's say basmalah together. Bismillahirrahmanirrahim. Officially, this conference open. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Bapak Profesor Dr. Muhammadiyah M.Si.A.P.T. Ladies and gentlemen, we finally come to the awaited moment, keynote speech sessions. Before it begins, I would like to read the curriculum vitae of the keynote speaker. Bapak Profesor Dr. Heris Hendriana MPD, a chairman of Indonesian Mathematics Educators Society or IMES, Bandung, Indonesia. He has finished studying in IKIP Bandung and Universitas Pendidikan Indonesia in the Department of Mathematics Education for the bachelor's degree, master's degree, and doctorate degree in 2009, and in Utrecht University, Netherlands in 2019. He has been participating in some professional organizations, consists of SCKIP Siliwangi, and has become a rector of IKIP Siliwangi and a director of postgraduate of IKIP Siliwangi. Besides, he also has some publications through years. Now please welcome our keynote speaker, Bapak Profesor Dr. Heris Hendriana MPD. The floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Good morning. The Honorable Vice Rector of UMS, Mr. Harun Muhammad and Prayitno, the Honorable the Deans of FKIP UMS, the Honorable Chief of ICOMER and the participant, and the Honorable for the speaker in ICOMER. I'm very happy to meet all of the participants today, and I will present the result of a preliminary study on the relationship about of HOTS and metaphorical thinking and computational thinking. Why is it necessary to look at the relationship about higher order thinking skill and metaphorical thinking and computational thinking? As we know, in the independent curriculum, there is a profile of Pancasila student as the main guideline for learning objective in Indonesia, which refers to global developments. Pancasila student profile include faith and faith, global diversity, working together, independent, critical thinking, and creativity. All of them are very important because they are in accordance with the demands of global developments, especially in 21st century, Industry 4.0 and Society 5.0. The orientation of 21st century learning in the form of various important skill masters by learner to become productive, creative citizen. As in this picture is a very relevant, make it very relevant learning orientation in Indonesia. Become subject in contrasting learning experience, practicing higher order thinking and developing habits of work. The focus of this initial study was higher order thinking skill. The characteristic of the current generation millennial or Z generation demand freedom in learning, but in their needs, goals, learning results, evaluation, and result. They also easily switch focus, interactive complexly with the media, have difficulty concentrating for a long time, and are happy with image, icon, symbol rather than text. Metaphorical thinking has power in freedom. Metaphorical thinking has power in freedom of thoughts, interpretation, and dialogues, especially from an event or symbol. Computational thinking has the potential to make a difference in a rapidly evolving world and provide significant benefit to individual and society. Accelerating technological advance and social demand that encourage one to rethink the core fundamental of computational thinking for a scientific approach. Computational thinking is a collection of approach to solving problem and solving them in a way like a computer executes them. Computational thinking skill can be used to build modern prototypes, to think about and interpret the world more closely. Therefore, computational thinking is also relevant for learning outside of academia. Therefore, computational thinking is one of the necessary skills to add in the future and have an impact on the field of education in many countries. Computational thinking include the composition, pattern recognition, abstraction, and algorithm. The purpose of this study was a look at the relationship between computational thinking, metaphorical thinking, and higher order thinking skill. This study was carried out by conducting several literature reviews and limited trial on new students of the PGSD study program. About higher order thinking skills is a transfer process, namely, which is the ability of learner to apply what has been learned to new situation. Hard is critical thinking, which is the ability of learner to think logically, sensibly, reflectively, and make decision. Hard is problem solving, which is the ability of students to solve problems. Problem solving is real life. Hard is in taxonomy Bloom. We know in taxonomy Bloom, hard is at the level of analysis, evaluates, and creates. Metaphorical thinking comes from the word meta, which means transcending beyond the real world, and pora, which is related to transfer. Metaphorical thinking is the process by which students learn to use metaphor to understand a concept. Metaphorming or metaphorical thinking begin with transferring the meaning of a new association from one above object or idea to another. Starting from the concept that students have known either based on experience or previously processes knowledge towards understanding the concept being studied. There are 6 steps about metaphorical thinking in learning. The first is connecting. Connecting is 2 or more different things, both objects and ideas, such as connecting the garden and the man. The second, relating, associating a difference in both objects and idea to think from those we already know or know, begins observing their similarities. Exploring is about exploring similarities, drawing on them, and building model, role-playing, and describing them. The fourth is analysis of the thing you have talked about. Therefore, you need to step back for a moment and see everything you just made. Transform an image, model, or object that you create, recognize, or discover something new based on your connection, exploration, and analysis. And the end is experience, applying image and a model or invention as much as possible. This means starting the creative process all over again. Some of the metaphorical concepts, from employer to call to a mathematical idea as provide, but this is the focus for me to research about metaphorical thinking and how the association with computational thinking, and to one of efforts to improve the higher order thinking skill. One is a grounding metaphor, which the basis for understanding mathematical ideas that are linking to everyday experience, like flower, like interpretation, like if we look something, we have some interpretation about model, about draw, and so on. Linking metaphor, which establishes a relationship between 2 matters by selecting, asserting, giving flexibility to, and organizing the characteristic of a primary topic with the support of a subsidiary topic in the form of metaphorical statement. Redefinitional metaphor, which redefine metaphor and select the most suiting one to the topic to be taught. In realistic mathematics, if we know about it, the transform from model of to model for. Yeah. And so, what is computational thinking? Computational thinking can be described as a structured strategy in order to solve problems and achieve the desired solution, which consists of 4 components. Yeah. Stage of computational thinking. The first is the composition. The composition breaks down data, process, or problem into more detail. This makes complex problem easier to solve. As an illustration, if someone wants to understand how an electric car works, it can be started by separating it into spare part, then observing and testing the function of its component. Then, by doing so, how the electric car system works will be easier to understand than analyzing from a large complex system. The second of computational thinking is pattern recognition. Is observing trends and regularities in the data. To illustrate, each cat has the same characteristics. Cat have a tail, fur, eat, fish, and meow. This general characteristic is called pattern. When we describe a cat, then we will describe the characteristic of other cats with the same pattern. Abstraction focuses on important information and ignores unnecessary detail. Although every cat will have something in common, but it has different characteristics. For example, there are cats that have different ages, color, and coats. There are cats that have a short tail. Some have a long tail. Abstraction will filter about the characteristic of each cat because irrelevant details cannot help to explain the basic characteristic of each cat. The process of filtering out the irrelevant and focusing on the most important models or information helps us to be able to solve the problems. And the fourth is algorithm. Algorithm design is to create a series of interactions in order to solve a problem or performs a task. When someone is going to use a computer to perform a specific task, then we need to design a program to execute the steps of those tasks. The step of the program designed to meet the needs of solving such tasks are termed algorithmic thinking. How well the computer performs depends on how the algorithm works. Algorithm design is also useful for calculation, data process, and various automated systems. For example, of computational thinking in the potential academic test, from example, the problems about higher order thinkings with computational thinking and metaphorical thinkings. From the problem of the picture shown, we analyze the thought process of thoughts relating to computational thinking and metaphorical thinking. The composition process, there are 16 elements in this problem. The first is Kubernetes, folded Kubernetes, place spreadly, surface difference, sign, point 1, point 3, square 1, square 2, and blanks, to slide. Kube is formed, bentuknya, the correct shape position is marked with this sign. Square 1 is opposite square 2. Point 3 is the opposite point 1. Blank opposite blank. Pay attention to the position of the cube in the answer choice. View E, square 1 is side by side with square 2. View B, point 1, adjacent to point 3 and blanks. View C, point 1 is the next to point 3 and is blank. View D, square 1 is adjacent to point 3 and is blank. And then pattern recognition. Yeah. Pattern recognition, we hide some number, not association with the solution about this. Okay. Point 1, point 3, square 1, square blanks, cube is formed. The correct set position is marked with this sign. Square 1 is opposite square 2. Point 3 is the opposite square 2. Point 3 and blank opposite blank. And then is abstraction. Abstraction. We have number 1 until 12 and 16. Yeah, and 16 of this feature. Algorithm of this problem solving is the cube nets are folded and placed freely, surface the difference contrasting sign. How the example of metaphorical thinking? Yeah, about metaphorical thinking in the same problem, computational thinking. Yeah, metaphorical thinking have grounding metaphor. Yeah, and there are 16 elements about this problem, and the 16 element is the same, yeah, or equivalent with the computational thinking. And then grounding metaphor, we have 7 element about grounding metaphor, about grounding metaphor. This is the independent thinkings, pre-thinkings about something like this picture. There are 7, and then linking metaphor. Yes, linking metaphor. We have 5 elements, 5 sentences about this picture to linking metaphor. How to connect it, one subject to one subject. The correct set position is marked with this sign, and so on. The last is redefinition metaphor. Yeah, pay attention to the position of the cube in the answer choice. View A, view E, view B, view C, view D, and so on. So, how about computational thinking in mathematics? Yeah, we have a problem. Yeah, the series number, yeah, and we must to correct and the blanks of this number. Yeah, we have the process 1 of computational thinking is decomposition. Decomposition is we makes a part of this series number. We makes 2 parts. Yeah. 50, 100, and process of pattern recognition. We have a pattern about part 1, part 2, yeah. And in abstraction, yeah, we hide or delete the information not necessary for the to solve the problems. Yeah, and the end we have algorithm to solve this problem. This like, yeah. And the another problem is we have the ratio between RD money and Fahri money is 5 and 6. If their amount of money is 132,000, hence the amount of RD money was. We have two type answer of new student or PGSD, new PGSD student, Yeah. There are two type of answer from student. Type 1, the student divides the total amount of money into 11 of the total 5 and 6 and gets the number 12,000 and give 5 parts to RD and 6 parts to Fahri. 6 parts to Fahri. Yes. Type 2, student use mathematical formula algorithm by multiplying fraction and multiplying by the amount of money. Both of type methods get the same result. RD money is 60,000 rupiah and Fahri money is 72,000 rupiah. Conclusion, in every metaphorical thinking, our computational thinking, the main ability that stand out are critical and creative thinking. When doing metaphorical thinking and computational thinking, then analysis and evaluation are carried out and even doing creation. So that the HOTS capability is an accumulation of metaphorical thinking and computational thinking capabilities as shown in the following diagram. Yeah. There are intersection about metaphorical thinking and computational thinking and becomes the HOTS. HOTS is intersection of metaphorical thinking and computational thinking. Thank you all of you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Bapak Profesor Dr. Heris Hendriana, MPD. Ladies and gentlemen, moving on to the next agenda, now it comes to the panel session. We already have Professor Dr. Ahmad Fauzi bin Muhayyub and Professor Dr. Budi Murtiasa MCOM with us as the speakers, who will be managed and moderated by Bapak Muhammad Toyib, SPD, MED. Before we begin, I would like to read the curriculum vitae of the moderator. Bapak Muhammad Toyib, SPD, MPD. He has finished studying in Universitas 11 Maret in the Department of Mathematics Education for the bachelor's degree and master's degree. He also has some publications and society service experiences through years. The Honorable Bapak Muhammad Toyib, SPD, MPD, the floor is yours.
Okay, thank you for Master of Ceremony. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning all. Honorable Rector and Vice Rector of the Universitas Muhammadiyah Surakarta. Honorable Dean and Vice Dean of Teacher Training and Education Faculty, Universitas Muhammadiyah Surakarta. Honorable our speaker of International Conference on Mathematics and Learning Research, distinguished participants, ladies and gentlemen. I am Muhammad Toyib. It give me great pleasure to become a moderator for this session. In this ICOMER, this is two part of panel session, and this is the first part. Please allow me first to welcome our speaker for this session. First of all, Prof. Dr. Muhammad Ahmad Fauzi bin Mod Ayub. Hello, Prof. Fauzi.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Right.
And the second is Prof. Budi Murtiasa. Hello, Prof. Budi. Okay, maybe next will join the session.
Assalamualaikum warahmatullahi wabarakatuh.
Okay, Alhamdulillah. Waalaikumsalam warahmatullahi wabarakatuh. Okay, ladies and gentlemen, first of all, I would like to read a brief introduction to our e-commerce speaker for this session. First is Professor Dr. Ahmad Fauzi bin Mod Ayub. He is the professor at Department of Foundation of Education, Faculty of Educational Studies, University Putra Malaysia. Prof. Fauzi graduated with a bachelor and diploma degree in Mathematics and Education from University Pertanian Malaysia, and holds a master degree in Information Technology from the University Teknologi Mara, and a PhD of Computer Education degree from University Kebangsaan Malaysia. The second is Prof. Budi Murtiasa. He is the professor at Mathematics Education Department, Faculty of Teacher Training and Education, Universitas Muhammadiyah Surakarta. Prof. Budi graduated with bachelor degree in Mathematics Education from IKIP Semarang, and held a master degree and doctor degree in Computer Science with specialization in Mathematics from the Gajah Mada University. Okay, without waiting for long here, we welcome our first speaker, Prof. Fauzi. Will deliver his speech about 45 minutes. Okay, for the next 4 minutes, the floor is yours, Prof.
All right.
Thank you.
All right. Thank you, Muhammad Toib, chairperson for these sessions. To all of you, thank you very much for attending my speech. Right. Straight to the point. So I'm sharing what topic given by me on enhancing mathematical and computational thinking in digital technology era. So before we go on the computational thinking in mathematics, let's look. So something that we need to understand that what is a computational thinking first. So basically, every day that we use the computational thinking in our life. So but then we are not aware of that. Actually, every day that we in our life we use this computational thinking. For example, let's say that we are going for a family vacation, and then we are planning to go to Indonesia. Let's say we go to family vacation in Indonesia. So the first thing, what are the things that we normally need to know? So the first thing that you will Google and look what are the interesting places in Indonesia. Let's say you are going to Bali, or you are going to Bogor, or whatever, Aceh and so on. So you need to Google first. So and then from that, after you have the information, and then you start to select which place that you want to go. Then you will decide how are you going to travel to that place. Either you going to by road or by plane, or by bus or by train, and etc. So then later on, you will decide which hotel that you're going to stay and what are the activities that you plan to go to do during your family vacation. So by right, all this process is a computational thinking. Then we go on this thing. So the other thing that something that we need to consider that every day, do you think you face a lot of decision or challenge every day? So every day, do you need to make a decisions? Every day, what are the challenges that you face every day and how many? So what are the action that have you taken? So how many thought that do you have? So all these things need computational thinking. So you are using your computational thinking for all these questions. And then it comes to this one. Okay, so basically computational thinking is the mental skill to apply fundamental concept and reasoning derived from computing and computer science to solve problem in all areas. Okay, like those who understand what is a programming, a computer's programming, so you know that we can to any computer, to for example, that you use any software. So before we develop this software, we need to have what we call as a programming. So the process to create this software, there is a lot of what we call computing process. So it relates what is the computational thinking with the thinking. So for example, okay, programming tells a computer what to do and how to do. So and then okay, but then computational thinking is not a programming. It is not even thinking like a computer, as computer to do and cannot think. But then it's more on computational thinking enable you to work out exactly what to tell the computer to do. So we are replicating in a computational thinking. We are replicating what are the process from a computer, the computer, the programming process to come with the computational thinking. And then, so in detail, okay, computational thinking describes the process and approach we draw on when thinking about problems or system in such a way that a computer can help us with this. So we describe, we start to thinking like a computer works lah. And then computer thinking is not thinking about computers like water. It's about looking a problem in a way that a computer can help us to solve it. So in this technology era, we use a lot of computers to solve our problem, to do things and so on. So whatever that we did in the computer, so computer will do whatever that we plan to do. Okay, and then computational thinking is an interrelated set of skill and practice for solving complex problem, a way to learn topic in many disciplines and necessary for fully this one. So computational thinking is not, as I mentioned just now, computational thinking is not much related with in the computer science, but then computational thinking can be used in several disciplines. Like mathematics, science, and all other disciplines can use this computational thinking. So in education, computational thinking is set of problem solving method that involve expressing problem and their ways and their solution in ways that a computer could also execute. So in education, we use this computational thinking for problem solving. So if we have any problem, so we solve this problem using this computational thinking. And then in mathematics, the computational thinking and mathematical thinking are used to decompose the mathematical problem. For just now, the keynote speaker have mentioned that think abstractly, produce or choose algorithm to the problem. So in mathematics, we use this computational thinking for a problem, to solve a mathematical problem, where we look into these mathematical questions, whatever the problem arises, then how we are going to solve it. Right. So basically, how this computer thinking works. So it's about a process. where we need to think about the steps that needed to solve a problem. And then based on this one, okay, we use our technical skill to work on the problem. Okay? Similar for we relate this computer thinking in mathematics. So we have mathematics questions. So we have been given a mathematics question. So from this question, we need to know what are the steps and what are the procedures, or how are we going to solve this? For example, in integration. So you have a question in integration. So we look that based on this question, you know what are the things that we need to use. We need to use what are the steps that we need to use, and then later on, after we identify that, then we use our mathematical abilities to solve this problem. Okay, all right. And then let's say another example that, okay, we normally use calculator to solve a problem maths. So in this case, we need to understand that to interpret problem before the calculator can help out with the arithmetic. Before you use the computer, before you use the calculator, so you need to understand and interpret problems. So we use the calculator to solve that, to get the answer. But before we get the answer, you need to understand and interpret problem. That one is before that we use the calculator. So calculator is only a tool that we have to get the answer. Okay. And then similar, if you want to create a multimedia product, so before we can create the multimedia product, we need to have the storyboard and so on, the storyline and also all the expertise. Then later on, we use this computer to get to have the products. So these are the things. So these are the things that related with the computer thinking, meaning that computational thinking is the thinking that is undertaken before starting work on a computer is known as a computational thinking. Okay. In mathematics, so how we relate this computational thinking in mathematics. So in mathematics, we will identify the key information in a problem before we solve it. So we in mathematics, we have the questions, so we try to think what are the key information from that particular questions. Then from this, we try to solve it. Okay, all right. So in computational thinking, okay, basically we have 4 steps. We have 4, what we call that, 4 process. The first one is decomposition. So in the decomposition is involve taking the complex problem and breaking it down into a series of small. So let's say we have a questions, we have a mathematical question. We look how this question can be. You can break down this question into a smaller questions, and that is much easier to solve. And then later on, each of these smaller problem can be looked at individually, considering how similar problems have been solved previously. So the next step is the pattern recognition. So after we have decomposed the question into the smaller one, so we look at for these small questions, how can we solve it? And then we have the third process, the abstraction. And then for the abstraction is focusing only on the important detail while ignoring the irrelevant information. And then the last step is the algorithm. In the algorithm is the step or rule that we're going to solve the problem. So these are the 4 process, and we want to do the computing skill. Thinking. Okay. And then we go in detail the composition. So as I mentioned just now, the composition involves breaking down a complex problem or system into a smaller parts, which are more manageable and easier to understand. So we have a bigger problem Okay, and then from this big problem, we try to slice it down into a smaller one. So it's much easier for us to decompose this, to solve this smaller problem compared to this bigger one. So as they are simpler to work with. And then this is because smaller problems are easier to solve. And then so if you have many smaller problems, so you will look the small problem one by one, and each problem can be solved independently. Okay, and then they can be tested independently, and there is not always one right answer. A problem could decompose in several ways. So maybe we have from one big problem, maybe we can slice it down into 2 or 3 smaller problems, and then based on, then you look for each and every small problem, this one, then you try to solve it. Maybe in a different way. So in mathematics, similar in the mathematics, we have let's say we have a word problem, big word problems, and we try to understand what are the components of the word problem and try to solve it in the smaller one. And then what are the different parts of the problem you are trying to solve? So this one, after you have decompose the problem into the smaller one, and then describe the main section of the problem you are solving and how could this problem be divided into a smaller part. So that is the important part in the decomposition. How could the big problem, you can divide it into a smaller parts. Okay, for example, let's say you want to know that how many different ways could make 17. Okay, for example, you can have 8 plus 2 plus 7, so get 17. But also we can have 9 plus 8, or 8 plus 9, or 9 plus 1 plus 7. So these are the several ways that we can get the answer. Sorry, this one is 17. All right. And then similar, if you have what we call that, a problem solving question. So let's say we have 5 apples on the tree. Some apples are red and some apples are yellow. So based on this, how many could be red? So you can have a different equation. You can derive different equation based on these questions. Okay, and in more higher mathematics, let's say you have you want to solve this integral. So you can see that based on this, you can divide this one is using the integral by parts. So you can break it out into this one. So these are the composition, and then we come to the next one, the pattern recognition. So in the pattern recognition is the process of recognizing pattern by using a machine learning algorithm. Pattern recognition can be defined as the classification of data based on knowledge already gained on a statistical information extract for this one. So in the pattern recognition, we try to solve a problem with a similar pattern. When we decompose a complex problem, we often find patterns among the smaller problems. So come from the decomposition, you have a very big problem, and then you slice the problem into the smaller one, and then you can see that based on the smaller problem, you can summarize, you can look on the pattern, how to solve this one, and so on. So it's much easier to solve in a smaller form. So the pattern are similarities or characters that are some of the problem are shared. So pattern recognition involves finding the similarities of patterns among small decomposed problems that can help us solve more complex problems more efficiently. And then these are the process. These are the processes of the following pattern recognition. Right. Okay. This is another example that I used to do. For example, this is the Sudoku. So let's say you want to solve this one, you will look on the pattern first, isn't it? You will look, and for each this one, for each box that you need to fill in, we will look on the pattern first. Then you will start you will start putting the service on the pattern. Okay, and these are some of the example for the pattern recognition. Okay, so you can see that to find these two numbers, you will look on the pattern for each and every from the series of numbers here. Okay, and then similar on this one. So to get the answer, you look on the pattern also. Okay, okay, this one. Okay, and also this example. So these are some of the examples related with the pattern. And okay, finding pattern is extremely important. So by identifying the pattern, so it make our task is much
sini.
Alright.
Ikut semua anggota di sini.
All right, and then we go to the next one. Toib, is it okay? Everything okay? Line okay, Toib?
Okay, bro.
Because there is an interruption there, so I thought that I have a problem with my area. Okay, the third process is the abstraction. Okay, so in abstraction is about simplifying things, identifying what is important without worrying too much about the detail. So abstraction is allowed to manage complex problems. So we use the abstraction in process. We start after we have the decomposition, and later on we have the pattern. Then we do the abstraction. The abstraction we start to eliminate, or we start to filtering what are the non-important things that we are not related with the questions, and then we just concentrate what are the things that we only supposed to do. So that is the abstraction. So abstraction in mathematics is the process of extracting the underlying structures, patterns, or properties of a mathematical concept. So removing any dependence on real world object which is might originally have been connected. So these are the process in the abstraction in mathematics. Right. So in mathematics, working with a word problem often involves a process of identifying the key. So let's say that we give the students so some mathematics word problem. So they will look at the questions, and then they start to eliminate. They start to pick up what are the important thing that they need to know. So these are where we start to do the abstraction. Establish how to represent the problem in the more abstract. For example, like these questions. So we extract what are the important facts from this one. Then towards the end we come up with the formula or equation or whatever. And the last process is the algorithm. So the algorithm is a plan or step-by-step, a set of step-by-step instructions to solve a problem. So if we have after we have identified what are the problem, and then after we identify what are the pattern and so on. So in algorithm, we need to know how to solve it. So it's a list of rules to follow in order to solve a problem here. Okay, and then for example, let's say you want to bake a cake. So the algorithm is that you need to have a recipe book, for example here. So in the recipe, so they will list out what are the things, what are the ingredients, what are the process that we need to do to make a banana cake, for example this one. Similar, if you want to find a petrol station, let's say, So let's say you are new to this town, so you need to go to a petrol station. Nowadays we have the Waze, and we have the map, Google Map, and so on. So you just log in there, and then we start to allocate. So they will give the instruction to set direction to get to the petrol station. So these are the algorithm. These are the steps that we need to do. So for example, in the petrol station, so you just follow the instruction given to get in order to get to the petrol station. So identify in mathematics, similar with the mathematics, if you want to solve a problem, a given problem, mathematical problem, so you need to know what are the formulas and how to solve it. So therefore you need your mathematical skill to solve this one. For example, what are the steps involved in the calculation of this one? So what are the steps involved in solving the integration question and so on? So basically, algorithms are the practical application of algorithmic thinking. So algorithms state the step required to get to the result and so on. Okay, so these are the 4 elements in the computational thinking. So we have the decomposition, where in the decomposition, we break down the problem into the smaller part. And then later on, after that, we go for the pattern recognition. So based on the smaller part, we observe the pattern and look how to solve it. And then we have the algorithm. So determine what are the steps are needed to solve a problem, and abstraction. So remove detailed and abstract irrelevant information. That one. Okay. All right. Let's say we come to how to apply this computational thinking. Let's say that you are planning to go to a supermarket, and let's say that you have a very limited time to buy all the groceries. So how can you make your trip to the supermarket as fast as possible while still getting there? So you have a lot of things to buy in the supermarket, but then in the same time you have a very limited time. So in this, so you can use this computational thinking during this process. So in the decomposition, you need to write down what are the things that you need to buy. And then pattern for the pattern recognition, knowing exactly what we need to buy. The abstraction grouping the item into smaller categories, and algorithm really this one. So these are the first step, decomposition. So you list down what are the things that need to buy from this supermarket. And then, so you group this thing either for under different category, fruit, vegetables, and let's say milk and so on. And so you have the list. So based on this list, you group it into different categories here. And then for the abstraction, so you need to look on the layout of the supermarket. So in the layout of the supermarket, they will have the each row or the allocation of this grocery thing that you need to buy. So in the supermarket, you need to be aware. For example, this one. So in this row, what are this row for? What are the second row, and so on. So you need to identify this one. You identify the things that the location of the grocery that in the supermarket, and the algorithm. So algorithm is that how do you plan to buy? Now after you have identified the location, so you say that, for example, this row is on the selling water, this one the coffee. Then for the algorithm, you need to plan what are the things you need to buy first, and proceed with others. So basically, these are the computational thinking, and computational thinking is much related in teaching and learning. So in teaching and learning, so computation must define what students need to know and be able to be successful as computational thinker. So if you want to implement computational thinking among your students, so but then you need to know how to develop this computational thinking to the student. So the cognitive process necessary to engage with computational tool to solve problem. And so these skills are the foundation of the problem solving. So basically in computational thinking in teaching and learning, they involve in 3 different things. First, the computational thinking skill, where you need the abstraction, decomposition, and so on. And then later on, you need to have the computational thinking practices. So after you have know what are the computational thinking skills, you need to practice. So you need to, for your student to apply this computational thinking, so you need to start to give questions in the class. You need to start to create activity that related with the computational thinking. So this will help the student to use this computational thinking frequently lah. And then the last one, we need to have an inclusive pedagogies. So we need to have this pedagogies include in our competition, in our teaching and learning. That's the only way we can create this computational thinking among our. Okay. So in mathematics, so these are the things that need to be considered if you want to apply this computational thinking. Firstly, the time. So computational thinking need a lot of time, a lot of time for the teachers and then for the students, because it involves more thinking to do, more and then also more time. And then we need to have the unplugged activities, and then also the real life example. And then we need to have a very simple concept. And also the last one, we need to have a reflection. After we have conduct this teaching and learning, we need to have a reflection so that the student can give feedback based on what they have learned and different. And these are the difference between the computational thinking in terms of the concept and the approach. So in the concept, we have the logic, evaluation, and so on. And then for the approach, we have tinkering, reading, and so on. Okay. And in mathematics, computational thinking is an approach to problem solving used by us every day without us realize. So I mentioned just now, in every day, so we use this computational thinking, but then we are not aware that we are using that one. So computational thinking is about taking a complex problem and being able to use several computational techniques, fully understand, decide if it can be solved, identify the key step, and create the effective solution. So similar in the mathematics, so we can see there is a relationship between computational thinking and mathematical thinking. So you can see that in this diagram. So these are the activity involved the computational thinking, and this one on the mathematical thinking, and this the intercept between computational thinking and mathematical thinking. So basically, we use tools for the computational for this the intersection. And okay, I leave it with these questions. To all of you. So let's say that we have this mathematical question here. How we are going to help our student to solve this mathematical question by implementing this computational thinking, which consists of the 4 process: decomposition, pattern recognition, abstraction, and algorithms. So we as a teachers need to understand how to implement this computational thinking to solve a mathematical problem. And for that, I would like to thank you to the organizers and to all of you for lending your ears for my talk today. Thank you very much. Okay, Toy.
Okay. Thank you very much, Prof. Fauzi, on your speech. Interesting speech for this session. Yeah. The Prof. Fauzi is explaining about computational thinking deeply, and its example in mathematics teaching and learning especially. Okay, ladies and gentlemen, all audiences, if you have some question, you have to keep it first until next 45 minutes. We will discuss in question and answer session. And for now, we welcome Prof. Budi Murtiasa to deliver his speech in the next 45 minutes. For next 45 minutes, please, Prof. Budi, floor is yours.
Gombong, stay. Please prepare yourself. Check your luggage and belongings. Make sure that nothing is left behind. For your safety, it is forbidden to open the train door before the train completely
Mungkin
stops.
sedang
Thank you for
di
choosing
kereta
train
Prof. Budi nggih?
services from Indonesian Railways Company. See you.
Oke, monggo untuk dipersiapkan Prof. Budi. You have to prepare the slide. Please share the slide presentation.
Passengers. Is forbidden.
My advice, can you hear, Mr. Tayyip? Halo, bisa didengar suara saya? Oke, bisa didengar suara saya, Mas Tayyip?
Yes, Prof.
Okay, thank you very much. Okay, for all participants, I would sharing information about computational thinking and mathematics education. This is about literature review. Yeah. Okay, Prof. Ahmad Fauzi have quite example for pillar of computational thinking. There are decomposition, pattern recognition, abstraction, and algorithm. Nah, okay, this is for pillar for computational thinking. Okay. This is my presentation. I would introduce about mathematical thinking, computational thinking, and computational thinking aspect in mathematics education, and promoting mathematical thinking and computer thinking in the classroom, and maybe the closing. Okay. Ladies and gentlemen, computer thinking is increasing focus in education, especially in key developed education. Yeah, maybe in primary education and junior education, and sometimes in high school. Yeah. Now, In Europe, primary education is maybe there are subject about coding, because in Europe maybe want to strengthen about computational thinking. Computational thinking attract much research attention. Nowadays in primary education and secondary education setting is more research about computational thinking. Also in PISA 20 and 21 framework, use computational thinking in mathematics as being part of mathematical skill. Okay. Now, what is mathematical thinking? Now, we know that problem solving is out of the mathematics. Now, mathematics is way to solve a problem. Mathematics actually is way to solve a problem. Now, being able to use mathematical thinking in solving problem is one of the most fundamental goal of teaching mathematics. So actually, if we are teaching of mathematics is how to teach of solve the problem. Mathematical, so the mathematics is not only important for solving mathematical problem and learning, but also for teaching mathematics. Okay. Now, what is mathematical thinking? According to Stacy in 2006, she has introduced about specializing. What the specializing is trying to special case, looking at the example. Maybe mathematical thinking is must be give an example. If you understand about definition, you must be able to make example. The second one is generalizing, looking for pattern and relationship. Generalizing is looking for pattern and relationship. The third one is conjecturing, predicting and relationship and the result. Make a predicting, make a relationship between among the component. The last one is about convincing, finding and communicating the reason why something is true. This is for pillar mathematical thinking. So we have also in the for solving the mathematical problem, is very famous method is introduced by Eufolia in 54 is the first one is understand the problem, make a plan, carry out the plan, and look back. Now, this is how to solve the problem according to Eufolia. It's this very famous method to solve a problem. Okay. Now we introduce computational thinking. Now, I think Ahmad Fauzi on the previous presentation have more quite example about computational thinking. Nah, according Denning and Tetri, computational thinking is mental skill and practice for designing computation that get computer to do job for us, and explaining and interpreting the web as a complex of information processes. So, by this definition, computational thinking is involved taking that complex problem and breaking it down into the series of small, more manageable problem. This is called as decomposition. Each of this smaller problem can then be looked at individually, considering how similar problems have been solved previously within recognition, and focusing only on the important detail while ignoring irrelevant information. This is called as abstraction. And the next simple step of route to solve each of the smaller problem can be designing. This is called as algorithm. Now, this is for pillar about computational thinking. Decomposition is a breaking down a complex problem into smaller problem, more manageable problem. Now, the second one is pattern recognition, looking for similarity among problem. Now, the next one is about abstraction, focusing on the important information only, ignoring irrelevant detail. And the last one is algorithm, developing step-by-step of solution to the problem. Now, for pillar of computer thinking, I think in the previous presentation by Professor Ahmad Fauzi have more example about this one. Now, so the main characteristic ability of computer thinking is the first one is formulating the problem, way to enable people to use computer and other tools to add a shopping item. The second one is logically organizing and analyzing our data. Nah, the third step is representing data through abstraction and model and simulation. Nah, after that, we are automating solution through algorithm thinking. Nah, the next one is identifying, analyzing, and implementing possible solution with the goal achieving the most efficient and effective combination of steps. And the last one, generalizing and transferring the problem-solving process by a variety of problems. Nah, this is according Costa in 21. Nah, so by this characteristic, nah, actually, initial set of computer thinking skill is maybe similar with ability to deal with open-ended problem. Now, I think open-ended problem is very familiar in mathematics. Now, the second is persistent in work through challenging a problem. Now, challenging a problem must be there is problem. Now, the next one is confident and dealing with complexity. The problem with complex, so we can decompose of the problem. The next one is presenting it into computational meaningful ways. Nah, the next one is breaking down large problem into smaller problems. Nah, then creating abstraction from this problem or aspect that problem at hand. Now, after that, we reframing problem into recognizable problem. Now, so then assessing or maybe evaluating the strength or weakness of representation of data or maybe representation of system. The next one is to generate algorithm, and the last one is recognizing and addressing ambiguity and algorithm. Nah, by this set of computer thinking, nah, Kalia in 21 at a result, there are many aspects of computer thinking in mathematical education research. Nah, the first one, among of them is automation. Nah, automation, abstraction. Nah, ini some object or maybe some focus on research in computer thinking in mathematics education. There are modeling also. There are algorithmic thinking. There are also a visualization. It's about decomposition. It's about pattern recognition, data analysis, testing, and debugging, data collection, data representation, generalization, evaluating, and tinkering. Nah, this about object or maybe focus research on computer thinking. This is study from Kalia et al. Now about computer thinking and mathematics education. Now, from this definition, we know that there are similarities between the problem-solving strategies which is used in mathematics and the process of computational thinking. Because use many skills in mathematical thinking, such as abstraction, decomposition, data collection and data analysis, pattern recognition, and debugging. So abstraction, decomposition, pattern recognition is actually a pillar for computational thinking. So in nowadays, there are characteristic computer thinking and mathematics education. According Kalia, there are about respondent is about 96% agree that characteristic computer thinking and mathematics education is about structure problem solving. There are about 22% is about CT is about algorithmic thinking to solve a problem. Now, the other one is agree that using decomposition to solve a problem. According to the respondent, also agree that computer thinking is actually logical thinking. Then the next one agree that about 96% agree that computer thinking is also include pattern recognition. And also using modeling to solve a problem. Abstraction is about 92%, and being able to transfer the solution of mathematical to other people or machine is about computing also. This is study about Kalia et al. In 21. There are also some research on computer thinking and mathematical thinking. The aspect of computer thinking and mathematical thinking, there are agreed that about decomposition. The aspect about decomposition is also very interesting topic in research on CT and MT. The next one is about structure problem solving is 100%. All operation men agree that actually CT and MT is about structure problem solving. The next one is about algorithmic thinking, abstraction, pattern recognition, generalization, logical thinking, analytical thinking, problem analysis, conceptual understanding, modeling, evaluating solution on strategy, and put. The last research is about good computational and mathematical thinking require an understanding the problem and the clear formulation of a plan. Understanding the problem, clear formulation of the plan is actually step up the folia on solve a problem in mathematics. It is about aspect of computer thinking and mathematical thinking in this research. No, there are computer thinking aspect in mathematics courses. Maybe computer thinking is also delivered on data analysis. Maybe on data representation, maybe on abstraction, maybe on decomposition, maybe on algorithm thinking, or modeling. Based on this aspect, note that computer thinking is mentioned when everything the learning of algebra, as well as those learning related to other fields of mathematics like number, geometry, and probability and statistics, and contribute to its development, highlighting the importance of algorithm and flowchart in mathematics classes. algebra is closely related to computational thinking. There are different book sequence and series on topic sequence and series. Now, the next one is there are about topic research on thinking. There are appropriate and statistics, there are sequence and series, number pattern, chain and relationship, or maybe algebra. I'm sorry, my connection is very poor. Okay. Character of the thinking and aspect in mathematics education. The first one is about problem solving. Problem explained very fundamental goal of mathematics education, in which computational thinking is embedded. The next one is thinking process. That is include abstraction, decomposition, pattern recognition, algorithmic thinking, modeling, logically, analytical thinking, generation and evaluation of the solution and strategies. And the last one, according to Kalia, is pressing the solution of mathematical in start with that it can be transferred of thought to another person or machine. This is transposition. Problem solving, thinking process, transfer, and transposition. Okay. Now, according to Sternberg, there is programming studying task familiar and playful concept to explore curricular mathematics content. So this must be embedded in mathematics curriculum. The usefulness of programming algorithm in particular to better understand mathematical concept. This is about computational aspect in mathematics education. Now, so how to promote mathematical thinking and computational thinking in classroom. We know that mathematical thinking and computer thinking are two interrelated and complex processes. So the skills such as pattern recognition, decomposition, design, the use of abstraction, use of primary computational tool, and the fiction of have been identified as part of mathematical problem-solving process. Mathematics provide a meaningful context set of problems which data can be applied. This means that problems on mathematics maybe can be solved using step of computational thinking. Computational thinking and mathematics can intersect, for example, in the application of software in mathematics and or computer science classroom. So maybe we must use appropriate software to solve the mathematics problem. When applying mathematical concept of software, both CT and MT are used to decompose the mathematics problem. Think abstractly, produce the choose a solution appropriate to the problem and debug any error that may arise. And the last one, computer thinking and mathematics education can be made as joint approach to encouraging problem-solving ability. But CT and FTS maybe actually can be enhanced of problem-solving ability. Okay. Okay, I think the last sentence of my mathematical thinking and computer thinking are problem-solving methodology. They involve pattern recognition in the structure of a problem. Good method, mathematical thinking and computer thinking, such as decomposition, algorithm, modeling, are maybe parallel step in good method. They also sub-heuristic strategy. Problem-solving behavior in common, such as abstract thinking, metacognition, trial and error, ambiguity, flexibility, and the ability of consider and evaluate multiple ways of solving problems. And maybe in the last one, mathematical thinking can be practiced in the context of computational tools and skill set. Conversely, computer thinking can be applied in the context of mathematics. Okay, I think this about my presentation. Thank you very much for your attention. I'm sorry because my connection is bad. Thank you very much.
Okay, thank you, Prof, for the great presentation about the computational thinking based on the literature reviews, Prof. And now we move to the Q&A session, but I have to inform you, Prof. Fauzi have another agenda, have a meeting, so maybe we can join the Q&A session, but you can still ask the question for Prof. Fauzi to Prof. Fauzi, and then I can forward the question to him. For the Q&A session, we approximately 30 minutes here. I invite to the all audience to ask the question repeatedly by orally to Prof. Budi or to Prof. Fauzi. Please, for the audience, if you have any question. Okay, here there is one question in the chat box. I will read it. Let me ask Prof. Fauzi or Prof. Budi, what are the differences between computational thinking and procedural thinking? And what is the position? Wait. What is the position between the two thinking skill? Thank you. Maybe because Prof. Fauzi have another meeting, and maybe Prof. Budi can answer the question. Okay, there is another question. Assalamualaikum, Prof. Fauzi. How to integrate city in one topic? For example, geometry or the other topic. Can you describe for one topic for our city step? Or this question is for Prof. Fauzi. So I have to forward to him. Maybe the answer that we can send to the what is Nur Khairul. Okay, Prof. Budi, are you still there? Okay, because Prof. Budi is on the way, so maybe the signal is interrupted, or maybe the full signal. We will wait to respond from the Prof. Budi.
Okay, Mr. Tayyip.
Okay. Thank you. Please answer the question, Prof. Budi.
There is question for me.
Yes, I have. There is the chat box, Prof.
That row. Okay, copy.
Okay, I can read the question, Prof. Budi.
Oh, sorry. Maybe
Okay, I can read the question for you. Okay. The question is, what are the differences between CT or computational thinking and procedural thinking? Differences between computational thinking and procedural thinking. That's the first question. For the second is, what is the position?
Right on the chat.
Okay.
Rather disturbance in this one.
Sorry, Prof. Maybe team can copy the question from the chat box to the Prof. Budi. Okay, Prof. The question I will read one more here. What is the differences between CT and procedural knowledge?
The different.
Get you the point? What is differences between CT and procedural thinking?
Okay, creative thinking and computational thinking. Okay, I think in creative thinking and computational thinking is maybe have common ability, common ability. Sorry.
Bagi Anda yang akan mengakhiri perjalanan di stasiun Kroya, kami persilakan untuk mempersiapkan diri. Periksa dan teliti kembali barang bawaan Anda. Jangan sampai ada yang tertinggal atau terluka. Untuk keselamatan Anda, tetaplah berada sampai kereta berhenti dengan sempurna. Terima kasih atas kepercayaan Anda menggunakan jasa layanan kereta api Indonesia. Sampai jumpa pada perjalanan berikutnya.
Dear passengers, in a moment we'll arrive at Roya Station. For those of you who will end your trip at Kroya station, please prepare yourself. Check your luggage and belongings. Make sure that nothing is left behind. For your safety, it is forbidden to open the train door before the train completely stops. Thank you for choosing train services from Indonesian Railways Company. See you on your next trip. Thank you.
Okay. Sorry. Can you hear my voice? Tayyip? Hello?
Yes,
Can
Prof.
you hear?
Yes.
Okay. Yeah. I'm sorry. Yeah. As we know, computer thinking is set up cognitive and metacognitive strategies, where with process and method of computer science. It is maybe formal definition for computer thinking. Now, what is different with creative thinking? Now, actually, if we want make a algorithm, we make abstraction, we make decomposition, we make pattern recognition as use of creative thinking. Nah, jadi this one need creative thinking to solve the problem on computational thinking aspect. How to make decomposition, how to make pattern recognition, how to abstraction, and make an algorithm. I think is needs of creative thinking. Needs of creative thinking. So creative thinking is maybe one aspect that used to support of computational thinking. I think this very short answer from me. This is my answer, Mr. Tayyip. Okay.
Thank you, Prof. Budi. This is differences between computational thinking and also creative thinking from Pak Gunawan. The question is, there are another question, Prof. Budi, from Pak Darmadi here. The differences between city and procedural thinking, Prof. Budi. The previous one is difference between city and creative thinking. But here Pak Darmadi asked the question, the differences between city and procedural thinking.
Procedural thinking.
Yes, Prof.
Procedural thinking. Yeah, okay. It's maybe procedural thinking is maybe like algorithm. Yeah. One of computer thinking is must be procedural. This computer thinking is the first step is maybe four pillar is the first step is decomposition, pattern recognition, abstraction, and make a algorithm. Now, this is procedure for memory. I think if we familiar with computational thinking, so this means that the student is also have familiar with procedural thinking. Because computer maybe is actually is linear procedure to solve up the problem. So if familiar with computer thinking, so actually the student also familiar with procedural thinking. So procedural thinking is also computer thinking is give ability for the student keep big habit, ya, keep the habit of procedural thinking. Jadi, if the student is make computational thinking, so actually computational thinking is keep habit for student with procedural thinking. I think it's this one. Okay.
Thank you, Prof. Budi. Maybe any feedback from Pak Darmadi or Pak Gunawan? Please unmute your microphone.
Enough.
Oh, enough. Thank you. Okay, audiences, we invite another audience to ask the questions. Please raise your hand if you can deliver the questions probably. Or maybe you can write the question in the chat box. Okay. There are another question. Maybe we limited to 2 questions for this session. No more? Okay, maybe the explanation for the computational thinking from Prof. Fauzi and also Prof. Budi is clear and also comprehensive. So there is no other question for education. I think we can learn much more for computational thinking and also the application in mathematics education learning. And for this session, I think enough for the Q&A. And if you have another question, maybe you can ask to from Fauzi and also from Budi by sending the email, and you can ask the question immediately to Prof. Fauzi or Prof. Budi. Maybe for the final session here in this morning session, we can close by the close remark from Budi. Is there any close remark for this session?
Okay, thank you very much for all. Thank you very much, Mr. Toyer.
Okay, thank you, Prof. Budi, on the great presentation for this session. I hope that we can get many information, especially in the computational thinking and also mathematical thinking. I think we end this session for the morning session. We will continue the next session after the praying, or also maybe some information will deliver by the conference team here. I would like to thank to all speakers, Prof. Fauzi and also Prof. Budi, for the informative and interesting presentation, and also to all the participants for the active participant. Please give applause for the speaker and also for you. Okay, thank you. I should remind everyone that we will be seeing you again on the second session. And so for this session, I thank you very much. And I offer to you, Ms. Bilfa, for the master ceremony. I end the session. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Number 3. Assignment letter 4. Number 4. Reminding that the technical parallelization is sent via email. The parallelization will be conducted in 3 days, starting from 14 to 16 September 2002. The presenter is stated to fill in the parallelization presentation attendance form with the following conditions. 1. Have uploaded a presentation video. B. Have commented on 5 presentation videos. Others are required to comment on at least 5 videos in their similar classes. And 3. Report screen capture of discussions to fill in the upload comment proof form. Announcement number 5. For speakers who have not joined the WhatsApp group, please be joined too soon with the link that has been sent via email. Number 6. For those who have not uploaded the video link, are given until September 15, 2022. And last but not least, number 7, the materials will be sent via email. All right, ladies and gentlemen. So we will have the next panel session with Professor Gyong Iver Moller, DSc PhD after break, starting from 11:30 a.m. to 12:30 p.m. Once again, I would like to remind all participants to fill in the attendance list through the link that has been sent via chat box. See you at 12:30 p.m. Thank you.
Jiwa dari Pulau Jawa, kekayaan budaya yang terus terjaga, melahirkan jiwa-jiwa bersahaja, menciptakan para intelektual muda yang siap mendunia. Di sini berkembang Persyarikatan Muhammadiyah, organisasi Islam progresif yang bergerak di bidang kehidupan, salah satunya pendidikan. Atas prakarsa Dr. Andes Haji Muhammad Jasman, pada tahun 1979, Universitas Muhammadiyah Surakarta berdiri sebagai gabungan dari Institut Keguruan dan Ilmu Pendidikan Muhammadiyah Surakarta dan Institut Agama Islam Muhammadiyah Surakarta. Universitas Muhammadiyah Surakarta hadir memperkaya kemampuan para intelektual muda, mewujudkan sarjana muslim berakhlak mulia, cakap, percaya diri, mampu mengembangkan ilmu pengetahuan dan teknologi yang berguna bagi umat, bangsa, dan perkembangan dunia. Di bawah pengelolaan yang profesional menuju world class quality, program studi pendidikan matematika Universitas Muhammadiyah Surakarta hadir dengan visi menjadi pusat pengembangan pendidikan matematika yang profesional, inovatif, dan islami. Dengan misi menyelenggarakan proses pembelajaran secara profesional, kreatif, dan islami, melakukan inovasi pendidikan matematika, serta menjalin kemitraan untuk meningkatkan kapasitas institusi. Program studi pendidikan matematika berupaya menghasilkan pendidik yang mampu mengelola pembelajaran matematika dan menghasilkan karya-karya inovatif di bidang matematika dan pendidikan matematika. Sejak tahun 2018, program studi pendidikan matematika Universitas Muhammadiyah Surakarta telah terakreditasi A. Penciptaan atmosfer akademis dan pembentukan karakter kompetitif terus ditingkatkan, sehingga kepercayaan masyarakat terhadap program studi pendidikan matematika Universitas Muhammadiyah Surakarta semakin tinggi. Hal ini terlihat dari banyaknya jumlah peminat yang mendaftar. Pembelajaran di program studi pendidikan matematika Universitas Muhammadiyah Surakarta didukung dengan fasilitas penunjang yang baik, seperti sarana perpustakaan, tempat mahasiswa dapat mengakses referensi yang relevan dan memadai, laboratorium pembelajaran, laboratorium komputasi, bengkel dan ruang display alat peraga matematika, Masjid Fadlur Rahman dan Masjid Hajah Sudelmiah Rais, serta Wi-Fi area. Program studi pendidikan matematika juga menaungi langsung himpunan mahasiswa program studi pendidikan matematika yang mampu menjadi wadah bagi mahasiswa untuk mengembangkan soft skill di bidang organisasi dan pengembangan diri. Selain didukung oleh fasilitas yang mumpuni, atmosfer akademis juga dibangun melalui tenaga pengajar yang telah tersertifikasi, baik secara akademis maupun praktis. Terlibat aktif dalam kegiatan akademis dan profesi berskala nasional maupun internasional, sebagai upaya pembaharuan ilmu pendidikan matematika yang dimiliki. Proses pembelajaran juga mengacu pada kurikulum berbasis kompetensi yang merujuk pada KKNI, Kerangka Kualifikasi Nasional Indonesia, melalui pendekatan metode pembelajaran saintifik, kooperatif, konstekstual, discussion, presentation, dan problem solving. Berbagai upaya yang dilakukan program studi pendidikan matematika Universitas Muhammadiyah Surakarta melalui pemberian fasilitas penunjang hingga menjalin kerjasama dengan instansi di dalam maupun luar negeri yang merupakan proses penciptaan atmosfer akademis yang kondusif. Diawali dengan kesadaran bahwa kecerdasan dan kesejahteraan umat adalah tanggung jawab bersama, sehingga memberikan yang terbaik dalam membentuk generasi penerus bangsa adalah satu tanggung jawab yang patut ditempuh untuk menjadi yang profesional, inovatif, dan islami dalam dunia pendidikan matematika nasional maupun internasional. Program Studi Pendidikan Matematika Universitas Muhammadiyah Surakarta, profesional, inovatif, dan islami.
Good afternoon all, for the audience and the speakers. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Head of Mathematics Education Department, Dr. Muhammad Nur Khalid, and the Honorable our speaker from University of Szeged, Professor Dr. Jansper Molnar, and distinguished participants from many countries. Ladies and gentlemen, firstly, let me introduce myself. My name is Muhammad Waluyo. I am a junior lecturer from Muhammadiyah University of Surakarta in Mathematics Department. I will be chair in this discussion session. Ladies and gentlemen, first I'd like to read a brief introduction to our speaker. Please introduce Professor Dr. Jansper Molnar. He's a professor of education at University of Szeged, the city of Sunshine. Her main research areas are technology-based assessment, educational measurement, and problem solving. She's a founder of EDIA, a well-known learning management system in Hungary, and the deputy project leader of developing diagnostic assessment project in Hungary. She got many awards or research funding, such as IVLP Fellow in 2015 in U.S. Department of State, and the professional leader of the Classroom of Future project at University of Szeged. And she also got the award of Jung Researcher 2006 of Academy of Science and the award of Innovative Teacher in Paris 2007. She also active in many national or reputable international journal as associate editor of Major Pedagogia 2004 till now, and the editorial board of Octatas Informatica, Education and Informatics, and Journal of Dynamics Decision, European Journal of Psychology, Knowledge and Learning, and etc. In short, she still has many other achievements that I cannot mention in detail. So in this occasion, she will present topic of digital revolution in mathematics education and the what and how of learning. So this is suitable with our circumstances where we are recovering from pandemic situation and we want to use advantage of the momentum of the rise digital learning in the pandemic time. So Professor Chansfir Molnar will share with us her experience in applying technologies to promote student experience in teaching and learning, particularly in mathematics learning. So before the presentation begins, let me tell you how this session will run. Firstly, speaker will present material about 40 or 45 minutes. Then we'll be following by question and answer session for approximately 15 minutes. And finally, session will be ended by summary. So ladies and gentlemen, please welcome our speaker, Professor Dr. Chansfir Molnar. Professor Dr. Chansfir Molnar, the times and the floor is yours, please.
Thank you, Valio. I think it's not the best way to share. Probably this way. Can you see my slides?
Yes, we can see it.
Great, thank you. So first of all, thank you for the really kind invitation. I would start my presentation with an analogy. Nowadays, your smartphone offers workout program and nutrition programs if you decide to put on muscles or to lose weight after entering a few important parameters, height, weight, age, gender, and of course your goal. As you have to experience if you do sport. As you do sport, your smartwatch continuously monitors your time, calories burned, pulse rate, heart rate. More accurate, personalized workout programs are provided for you based on these data. In parallel, technology can contribute to personalizing education by even predicting what type of tasks and activities would be most beneficial for different students. But the question raises here where we are today. As even Valio mentioned, the pandemic, more specific, the school lockdown in response to pandemic, COVID-19, is thus having a massive impact on educational activity. It has called additional attention to the potential and need of technology in education and to the lack of its adaptation in real-life school practice in mass education. Let's see the effects of school lockdowns in response to COVID-19. As you even have the experience, in a matter of weeks, entire educational system from elementary to higher education and to completely transform activity to evolve to an online teaching learning scenario. And this happened in all around the world. They had mostly focusing, of course, at very first on infrastructural issues. So the reality of the new normal, because this situation is called in the literature the so-called new normal, disrupted by COVID effects, has evolved a radical digital transformation of education. This phenomenon has accelerated the spread of the application of technology, accelerated digitalization to the worldwide educational system, enhanced teacher cooperation, which is a very positive side effect of all these issues. And this enhancing teacher cooperation story can boost really the effectiveness of learning. What has happened in education? What have we experienced? There is not enough infrastructure at both sides. That is, at first, we must have an infrastructure and service transformation, providing at least the minimal infrastructure to both teachers and students. There is also not enough digital competencies, again, at both sides, students and teachers. Our students of today are known like digital natives, millennials, net generation, digital generation. But we faced with the issue that they don't use really their phones, their tablets, their technologies for learning, but for different purposes. We also experience that there is a lack of proper methodological knowledge from teacher side, because frontal teaching methods in digital environment, it's not the best way of how technology can be applied in education. And all these resulted in mostly unmotivated kids. Children of today have been surrounded by digital technology, if I want to bring quotation from Livery, which has been embedded in their daily life, as we can say, really every day. However, they are not necessarily able to integrate these technology into meaningful practices and take advantage of what they offer regarding learning. That's resulting in a much larger digital divide than we are experiencing at present, because there are really large differences in opportunities to access these technologies between the different kids. There are certain paradoxes and delusions associated with next generation that needs to be considered, as the belief that I already mentioned that they know all about ICT is a fatal misconception. As a result, the so-called digital natives have shown limitations in the use of technology if it's going about learning. Several problems could have been solved, and several problems wouldn't have been raised if they could use technology for learning, if they have learned how to use technology for learning. So it means that there is a stronger need for proactive technology usage, critically considering how it could and should be used. To sum up, everybody have learned that digital transformation of education, more specifically, technology-supported education, is about more than just technology. It's not enough to apply the technology the same way, mostly in form of frontal teaching, as we run face-to-face teaching, because it does not work. As I mentioned already, this results in unmotivating kids. The realization of the effective computer-supported education is very difficult and highly complex undertaking for educational systems, even in the best circumstances. The goal is to adopt new ways of working, to use technology to support personalized education. School systems, including universities, must seriously rethink and redesign their education. They have learned that technological transformation of education, or simple computer-supported education, involves profound changes, not only in the infrastructure possibilities, but in teaching methodologies, essential competencies, and assessment methods. Without this, computer-supported education cannot be successful. Everybody had to do the first step. It's very important, the so-called infrastructure and service transformation, because without tools, without computers, we cannot fulfill this dream. that the present situation have created not only opportunities for transforming and reshaping education, but also highlighted the difficulties and challenges in this process, and there are really many. If you take a look on this figure, it visualizes the learning gap, the learning loss of the students in Hungary at elementary level in the field of math, reading and sciences in 2020 and 2021. And as you can see on the figure, there are huge learning gap, partly as a result of this teaching, using frontal teaching via Zoom or other online platform. It does not work. And if we go further and we look at the same analysis, which was run among lower grade SES students and low SES students, the learning gap is immensely. It's as great as if they had no teaching, or as if they had a summer break since 2020 when the pandemic started. However, we had school personally in the last year, but they get sucked at that point when pandemic started. Based on this, we assume that despite the fact of having mostly normal teaching time from autumn 2021, this learning loss has accumulated further and pronounced even larger gaps and learning gaps behind non-low SES students. So the problem is really huge, and technology could be a tool for solving all these issues, which really strengthened and raised in the last 2 years. But to tell the truth, we can even raise the question, how could it happen when research and educational technology-supported education goes back several years? Moreover, its application started more than 100 years ago. So it means ICT has long been a tool of supporting education. The use of technology in education started in the 20s, as you can see on the picture, and motion pictures and Sydney's Press's automatic testing machine were applied and launched. If you not remember, but know from school, radio in the 13s, television in the 15s, and program instruction in the 16s. The instruction of World Wide Web in the 19s brought about a massive change in many sectors, as well as in the research activity regarding education. If you take a look at this figure, which shows the frequency of the publications on technology in education from the 90s or in Scopus, and as you can see, it's continuously, exponentially increasing. So it's an interesting question, how could it happen that in time of COVID, 20 years after the millennium, we are there, that our teachers try to apply frontal teaching via technology, if it's going about technology in education. Let's see the main stones in research in the field of education in the last 30 years. First, in media comparison studies, researchers compare the learning outcomes of students who learn with one medium versus the learning outcomes of students who learn with another medium. However, this paradigm is problematic to the extent that learning is caused by instructional methods rather than instructional media, and learning is caused by the instructional method afforded by instructional media. It's very important that the fact that we bring technology into the classroom, we bring technology into education, we won't have a qualitatively better education. It's just a tool, but the instruction which really counts. After the millennium, the main research question was no longer whether the integration of technology in education affects the effectiveness of learning, but the main question sounds how to maximize it to increase the effectiveness of learning, and to use of educational technology should be based on research evidence and grounded in scientific theory rather than follow from grand promises and rosy predictions of visionaries. As you can remember at that time, Second Life was really a top platform, and there were really large promises in this platform, but it's just a platform, it's just a tool, but not the methods how we technology in education. So in short, an important message here that the ways must be devised to adapt these technology to the human mind, including how we learn, and research evidence is needed to determine which instructional features are most effective. Instructional design principles are useful for maximizing the effectiveness of computer-based learning situations. And again, we are at the same point. The simple usage of technology is not enough. We must reshape the what and how of learning. In the last few years, researchers in technology-supported education are not focusing only on learning outcomes, such as knowledge, skills, but also changes in learning processes involving motivation and engagement during learning. Today's educational technologies provide fine-grained, process-oriented data at every click of the mouse, tracking time spent online reading or working on a unit, and other details can open up new pathways for understanding how people learn. Intelligent tutors that provide formative feedback have a great potential in the field of education. And even if you look at the top publication in this field, they are focusing on these issues nowadays. The tools of learning analytics, the analysis of computer-recorded data on what students do during learning, can be useful in understanding the underlying learning processes for each learner, and ultimately in adaptation instruction accordingly. So we can learn a lot about students, how they learn, how they read the instruction, how deeply they understand all these learning material. Such affordances of contemporary educational technologies require development of new learning theories and reconceptualization of research, because most of the learning theories are based on knowledge which was created almost a century ago. So integrating the knowledge we gain in psychological research, integration, the results of learning sciences, educational researches, a lot of field is needed. So the cognitive theory of multimedia learning is based on the idea that people have separate channels for processing verbal and visual material, but only a limited amount of processing can occur in each channel at any one time, and deep learning occurs when the learner mentally selects relevant information, organizes it into a coherent structure, and relates it to relevant prior knowledge. It's very important. It means that we cannot do 5, 10 parallel things at the same time parallelly. It does not really work. Learning won't be as effective as if we concentrate on one single thing, what we have done earlier before such technological tools. Instructional methods used with educational technology support or should be understood in terms of the underlying cognitive processes they are intended to foster. A potential benefit of various educational technology is the positive effect on students' motivation and engagement, and not negative, as we experienced during COVID time and the kids and the teachers with technology. Relevant motivational theories include interest theory, which was that people try harder to learn when they are interested. Expectancy value theory, which was that people try harder to learn when they value what they're learning. Self-efficacy theory, which was that people try harder to learn when they feel confident about their competence to learn the material. And self-determination theory, which was that people try harder to learn in situations where they feel competent, autonomous, and related to others. The challenge of applying computer-based technology in education is to identify evidence-based and theory-grounded principles for how best to adapt the affordances of technology to help people learn, rather than to expect people to adapt to every new learning technologies that comes along, because it's impossible, really. Technology developed so quickly, and these tools develop and changes so quickly that it is not really realistic. So broadly speaking, educational technologies have brought about developments and challenges in theory, methods, and practice. And again, in all of the studies in the field of technology-supported education, fundamental questions should sound: how can we best use technology to help students learn? To answer this question, rigorous experimental research is needed to identify instructional features in technology-rich environments that maximize learning outcomes and promote appropriate learning processes. Why is it important? Why is the one-size-fits-all approach inefficient? And why do we need to change the what and how of learning, and not only the tools, blackboards to whiteboards and papers to computers? Because age does not determine skills and abilities. There are several years in knowledge and skills developments among students at every level of educational system. Here brought results from two different fields: problem-solving skills, which is not really explicitly enhanced in the school curriculum, and mathematical knowledge, which is explicitly enhanced in class at school. As you can see, regarding problem-solving, there are several years differences between students' knowledge in the same age. On the x-axis, you can see the grade. On the y-axis, the ability level of the students. And if a circle is larger, it means that that ability level, there are more students. And as you can see, the differences are huge. Really, there are students in 3rd grade who overachieve, mean achieve to the 9th graders regarding problem-solving skills. And even there are students at 9th grade whose achievement is below the average achievement of a 3rd graders. If you take a look of a similar figure which was drawn in connection with mathematical knowledge, we can face several issues. So the differences between students in the same grade are immensely. So it means that we cannot use the same method, the same instructions, the same curriculum for teaching those students, because it cannot be effective. It is not effective. But technology can help to address this issue and personalize education. So question for both teaching and learning: how to use of technology can reshape the methods of traditional teaching, how it could be maximized to increase learning effectiveness, support differentiated instruction, boost students' concentration, raise their limits of endurance, and maintain their motivation. COVID-19 can be emphasized as an opportunity for reimagining and digitally transforming, at least starting this transformation in the field of education. Let's see the what of teaching. Schools typically teach the same content to all students at the same time, at the same age. However, as you could see earlier, age does not determine skills and abilities. That the same content cannot match the readiness and needs of all students. As a result, the school material may be perfect for some, but too difficult or too easy for others. Technology can help to address this issue and personalize education. However, to do this, we need to know how skilled our students are. What do they know in the most important domains of education? especially in the field of mathematics. So the profile of assessment should change that goes from a summative, exclusively evaluation-based approach to a diagnostic, more learning-centered view to use assessment to facilitate learning. Let's see briefly the possibilities of technology-based assessment. At first, the possibilities of adaptive testing, if it's going about the what of teaching. Educational assessment is among the most dynamically developing areas in education since the turn of the millennium. In this period of large-scale international assessments, just think on the OECD PISA teams assessments have become regularly administered by world's leading test centers, resulting in a huge improvement of data transfer technology and data analysis methods, because we have learned a lot based on these large-scale assessments. 2 decades ago, paper-based assessments were the most widespread and accepted mean of assessment. Even PISA teams started with paper-based assessments. But due to rapid development, a qualitative change and a new kind of assessment had to be made to meet the learning and assessment needs of the 21st century. And now, if you know PISA, or if you look it up, you can see that even PISA and teams decided to apply technology-based assessment in the future in their data collections. The direction of these developments has been determined mostly by the computers, of course, because computers offers the most possibilities in the field of educational assessment. We can administer tasks in a more realistic, application-oriented, engaging, and authentic context with computer-based assessment. We can use innovative item development opportunities, producing dynamic, interactive multimedia items. We can design more valid assessments. For example, using an audio version of the task and instructions, we can exclude the level of reading skills of the students from the final achievement if we're focusing on measuring mathematics, because in most of the cases, if we provide problems in math context for the students, they have to read. So it means that in the final achievement, we also measure their reading skills and not really just the mathematical knowledge. So technology-based assessment makes it possible to provide instant, objective, standardized feedback, thus replacing previous long feedback times, and to use adaptive test algorithm to feed the difficulty level of the task, knowledge and skills level of the students. These issues, instant feedback and adaptivity, were also among the secrets that make video games so popular. We do not need to wait weeks or longer to receive feedback on our performance, and it's very, very important in the learning process. And we do not need to solve problems which are too difficult for us. If we have to wait days, weeks, or months for feedback, or start playing the game at a level that is too difficult for us, or have no success, or if it's too easy and poses no challenge for us, we will never ever play that game. These are the areas where technology-based assessment and game-based learning are converging with numerous innovative possibilities in both. So today, computer-based assessment offers more effective assessments than traditional paper-based or face-to-face testing. They are cheaper, data flow is faster and safer, indicators of test goodness are higher, students' motivation is higher, and as I mentioned already, feedback is significantly quicker. What do we know in 2022? In 2022, there is no longer any question whether we can develop complex, real-world, authentic, high-quality tests in the field of technology-based assessment. COVID-19 related school closure and digital teaching have reinforced the idea that one-size-fits-all approach is not effective, either in general or in educational assessment in particular. The almost exclusively used summative test results do not provide actionable feedback for learners to aid in improving their learning process. This is also the reason why, if you look at the stories and look at the decisions which was made during COVID pandemic in the US, they even quit school leaving exam because it's really strong, the summative test, and a lot of issues raised regarding summative testing and the validity of summative testing. So it means that this is a good reminder that beyond summative, high stakes testing, a more learning centered, low stakes approach using the power of prompt, proper, that efficient feedback is relevant and adequate. Like the word of video games, task and test, which must students' ability level with objective feedback, are also motivating and can even result in flow and enable teachers to tailor instruction and support students' development more effectively. As I've mentioned already, the profile of assessment should be changed from a summative approach to a diagnostic, more learning-centered view, use assessment to facilitate learning. Let's see diagnostic assessment. If we want to realize diagnostic assessment, what do we need? We need theory, we need frameworks, we need assessment platforms, and we also need tasks, a lot of tasks based on theory. And all these tasks should be put in item bank, running on the assessment platform, which we have developed because of this issue. We want to realize diagnostic assessment. And of course, we need a scaled item bank. Why? The diagnostic assessment system serves its function when it becomes through identifying all important knowledge elements of what students already know and what they still need to learn as it covers them. So in the history of education, three main goals have remained clear from the very beginning of schooling and public education up to the present day. First, to cultivate students' minds, general cognitive abilities, and thinking skills. Second, to develop usable, transferable, applicable knowledge. That's knowledge which is applicable inside and outside of school context. And third, to transmit content knowledge accumulated and organized according to the values of the sciences. So in modern societies, this three-dimensional learning, so the disciplinary, the application, and the reasoning dimension of learning should be present simultaneously, reinforce and interact with each other and not compete for teaching time. So it's not a good issue if we're focusing only on developing our students' disciplinary knowledge or the reasoning dimension of knowledge or the application dimension of knowledge. So taking research results in developmental psychology and learning mathematics, reading and science into account, we developed a three-dimensional model of mathematical and scientific knowledge and reading, distinguishing the direct curricular aspect, the reasoning aspect, and the application aspect of knowledge, as you can see on the figure. So for example, in case of mathematics, the psychological dimension has been conceptualized as the interaction between students' cognitive development and learning mathematics at school. The question in this dimension, how learning mathematics can contribute to the development of specific reasoning skills, and how effectively it stimulates students' general cognitive development. The application, the literacy dimension, the social cultural dimension, the question can raise in this dimension the following: how students can construct mathematical models of problems they face, how well they can mobilize mathematical knowledge to solve problems. And finally, let's see the question in the disciplinary dimension: how students progress with their daily mathematics studies. Now, if I recognize that the camera is not working, so yeah, now you can see me, but then it switched always off. Sorry for it. I don't know the reason for it. So let's see. The assessment platform, how it should be built and how it should look like. It should be a learning-centered platform, which is easy to use, but it also contains innovative possibilities. It should contain an item builder model for first, second, and third generation tasks, and it should be able to administer both fixed and adaptive tests as any device, even by low-speed internet connections. It should be able to provide prompt and quick scoring and good feedback model, which contains embedded visualization, even for both for teachers and students. Let's see the tasks, diagnostic assessment task. Several thousand tasks based on theory is needed if we want to realize diagnostic assessment, which are empirically scaled and which is running in a labeled item bank. So that all sounds pretty unfeasible if we think on all these. But to tell the truth, we managed to do this in Hungary within the confines of the EDA online diagnostic assessment systems, which now realizes, includes assessment and both learning. We can realize personalized learning within this framework, the three-dimensional model of knowledge. This platform, this system, can be applied as any device. It can administer innovative items, so it means third generation items, which is really similar to paper-based task, and even third generation items, which contains innovative elements where students can interact with tasks and with the surface. And it even includes a detailed feedback module. As you can see on the slide, teachers receive number-based feedback, and even we provide them this cobweb style figure, which includes students' level of skills for each student, and the red marks the student's achievement, the green is the country level mean, and the blue are the classmates' achievements in the different fields. So at present, the ADA system contains more than 25,000 innovative multimedia-supported empirically scaled tasks and provides students and teachers regular feedback from the beginning of schooling to the end of the 6 years of primary education. Beyond students' level achievement and national standards, teachers receive feedback on the class and school level results in comparison to regional and state level achievement. So teachers receive really a detailed feedback about their students, and they cannot only see their achievement within the class, but also how developed these students are on state level or regional level. So I also brought some tasks for you. This is a reasoning task in the field of mathematics. It combines the mathematical concept of whole numbers with the assessment of students' inductive reasoning skills in a familiar cartoon. And as you can see on these slides too, this is another reasoning task. It contains a loudspeaker, and it means that the kids can listen to the instructions. So we can absolutely exclude the reading skills, and they can just focusing on the math part of the task. This is an example from the application dimensional, where they have to put bears, 10 bears on the bed. This is again another task. Again from the application dimension. As you can see, they can use drag and drop, they can use inboxes, they can use clicking, so highlighting pictures or elements of the task by clicking. So we have many possibilities in this, many item types in this assessment platform. This task is an example from the disciplinary dimension, and this task integrates the understanding of number symbols, the operation of addition, the comparison of quantities and numericities, and the knowledge of realization symbols. If you look at it, there are drag and drop lists in this task, and even students can listen to the instructions every point of the task. And finally, again, a task from the disciplinary dimension, which they have to click to indicate the right answer. So we also have many partner schools in Hungary. It means at about 1/3 of the elementary schools are partner schools of the systems, and they use rarely or more often system in their daily teaching process. So we could prove that technology-based assessment is applicable in educational context at every level, because we also have researchers on kindergarten level up to higher education. And we also managed to prove that disciplinary application, the application and the psychological, so the reasoning dimension of learning mathematics, reading and science can be empirically distinguished, and they are independent of the measured grade in each grade. So it's a very important research result. If you take a look of the item person map of our item banks in the field of mathematics, so it means the items fit our students' ability level. So the item bank is appropriate to measure our students, 1st to 6th grade students, Matematika knowledge in these 3 dimensions. This system is appropriate to make learning visible, not only in the 3 domains of learning, but even beyond on other fields of assessment, other fields of learning. Here you can see an example from an inductive reasoning test and an example for an ICT test. So our future plans is to administer the task on an adaptive level and make better use of the impact of visualization in feedback that's offering teachers an interactive feedback model with highly integrated visualization techniques. During COVID pandemic, at the very beginning of the school closures, we launched a new model of the EDIA system, the so-called EDIA kindergarten test model, and made the so-called EDIA teacher test model available to everyone. Both are free and available for everyone. The kindergarten model contains more than 2,000 innovative reading, counting, and science tasks developed for kindergarten-age children, while the teacher test model contains all these 25,000 tasks used by the diagnostic assessments. The tasks can be filtered according to different domains, topics, subtopics, grade, and difficulty level. Then from the selected task, online test or mini developmental training with prompt feedback can be generated by the teachers, and all these for free. All the students need to solve the test is a technological device with an internet connection, computer, tablet, smartphone. As you have seen already, the system is possible to test the effect of disruptive education in the last year. And finally, let's see the how of teaching, because the what of teaching is not enough to reshape. We also need to reshape the how of teaching. So the digital transformation of technological supported education should also require the how of teaching to change. It's very, very important. The learning strategies in a digital or computer supported learning environment are not the same as those used by students in a more traditional face-to-face classroom, where students are asked to recite, repeat, and remember knowledge in a way that it's largely devoid of any meaning, without any attempt to tie this knowledge to anything in their lives. Schools should educate the young generation for tomorrow, for the needs of the future. Students have to learn how to be proactive towards technology. They should critically consider how it could and should be used. They have to be taught by new methods like cooperative learning, collaborative learning, and problem-based learning at all levels of education. That it's before teaching and learning. The preliminary question is how to use of technology can reshape the methods of traditional teaching and how it could be maximized to increase learning effectiveness, support differentiated instruction, boost students' concentration, raise their limits of endurance, and maintain their motivation, as I've mentioned at the very beginning of this presentation. Overall, the need to rethink the teaching methods used in education, including higher education, is due to the change in the students and their needs in education, the rapid change in the labor market, and the emergence needs related to lifelong learning. Technology is the supportive medium for the effective implementation of all these changes. So these changes are often identified as the digital transformation of education, although fundamental methodological change is needed, not only in technology, but also in perspectives. So it's going more about not only instructional changes, but methodology, instructional changes. Let's see educational technologies of the future. One of the educational technologies of the future will be intelligent systems that incorporate sophisticated learner and teacher models. They will monitor and model the emotional, metacognitive, and cognitive states of learner, and we interact with them through avatars that function as a pedagogical agent. The system will support collaborative learning and simulate agents with whom the learner can practice to improve cooperative learning skills. Applying adaptive models of assessment to each learning activity allows for continuous assessment and increases accuracy, although challenges about in embedding those diagnostic dynamic assessments in multimedia learning environment. And finally, we can realize that the smartphone offers learning programs for you based on your earlier learning and achievement. As you learn, your smartwatch continuously monitors your learning process and efficiency. More accurate, personalized learning programs and explanations are provided for you based on these data. That technology can contribute to personalizing education by even predicting what types of tasks and activities would be most beneficial for you. So the main key takeaways, fundamental question sounds: how can we best use technology to help students learn? We should leave the fitting for all approach. We should change the what and how of teaching. We need evidence-based, theory-grounded, rigorous experimental research in this field, and we should use the advantage of technology as a tool, supportive medium, rather than expected adaptation to every new technology. And we should focus on personalized learning and personalized education. So thank you for your kind attention. And sorry for the technological issues. I've just sometimes realized that my video was not running, so it's interesting.
Okay. Thank you for your presentation. Wait. That was a very comprehensive presentation. Now ladies and gentlemen, after we know about the comprehensive outlook of technological application in mathematics education, now it's time to have a discussion with our speaker. Ladies and gentlemen, now we are glad to receive many questions, but due to the time limitation, we are going to select around 3 questions first for our speaker. Now, let us see who see the question from the participants. I invite those who want to question or comment can raise their hands and open their microphone and can mention their names and where they come from. Please, for the audience, any comment or questions? Oh, anyone? Okay, maybe we can start from the question. Maybe it's to enhance technology. Okay, this is first. There is a question from Nur Khairo Siregar. Can you open your microphone?
Yeah. You can my voice, sir. You can hear my voice.
I can hear you. Yes, you can continue.
Okay, hi, Prof. Thank you very much for your deliver your knowledge to us. And now I want to ask you one question. I teach in elementary school, and I stay in the rural city, the rural area. So I have many I have many problem to teach the mathematics because many students they not have the how to say the technology in their house. So how to manage this problem? Thank you, Prof.
Okay, maybe can you take the point, John Smith?
Yeah, that's the reason why schools are playing a very crucial role in our students' life, because theoretically schools should bring the balance. And if a student does not have the opportunity in their home, in their own home, then the school should bring this opportunity to their life. So if the schools have computers and if the schools have the possibilities, then there is the chance to bring these students to the level that they won't have this problem later in their life. So it's also problematic in several countries in the world that the kids don't have infrastructure at their home. Even in Europe, there are students coming from very low SCS families that they don't have such infrastructure at home, but the schools should provide them the technology, and even the schools should teach them how to use these technology in a meaningful way. Because even if you take a look at students who have many technologies at home, computers, tablets, some of the students have even several phones, not only just one. They don't use it for learning purposes. And it means that that they have no advantage because the tools are not used for learning purposes. And it's a brand new topic which has a really big debate in the literature, and that this generation who raised with phones and TikTok and such platforms, they spend many hours in a day clicking their phones. Their brain reshapes somehow, and they won't be as effective in learning as students who doesn't do this. This is the reason why it's very important that we teach our students how to use technology for learning, that they learn how to use technology for learning, and somehow, hopefully, if we provide them game-based training, which they really enjoy, then we can exclude these huge problems that they won't be able to focus anymore because their brain changed completely as a result of this clicking thing. There is a big issue and hard around this, and little large researchers are running around this issue.
Okay, I hope this will answer your question, Miss. Well, we can continue for the second question from Mr. Andi Muhammad Irfan. Can you mention your name, your institution, where you come from?
Okay, thank you very much. My name is Andi Muhammad Irfan Taufan Asfar. Can you hear my voice?
Yes.
Yes.
Okay, thank you, ma'am. I'm from Universitas Muhammadiyah Bone, Muhammadiyah University of Bone. Okay, this is very interesting topic, I think, from Mr. Molnar, because they have relationship with the traditional in South Sulawesi, I mean, because in South Sulawesi have a lot of a traditional game, I think so. Maybe I just want to make it these traditional games to in educations, but more a barrier a technology to make it this happen. So do you have any tips to combine the traditional games into combine with technology to make it this happen in educations? I think because in traditional games in South Sulawesi, I mean, especially for Indonesia, have character to have relationship with education. So I just want to know your tips to make it this happen. Thank you very much.
Yeah, as I've mentioned, technology won't solve educational problems. So technology is just a tool, and if you have brilliant games without technology, then it's perfect for the kids. So the main message in my presentation would be that we should realize somehow personalized education, that we teach kids what they are prepared for, and then this is the best way to develop and train them. And if you can realize it without technology, then we don't need technology. Technology is just a tool which helps us to achieve this aim, realizing personalized education. But if you have games and tools where you can realize this without technology, then you don't need to use it. So it's just a tool, as a ball, as a chair, as a table. It's just a tool which can help increase the quality of the education, but not the tool, but which is important, not the computer, not the tablet, not the phone, but the method, the instruction, the game itself, which is important.
Okay, thank you very much for Ms. Molnar. It means that I just want to applying direct to my students. Okay, like that.
Okay, thank you, Mr. Andy.
Yeah, thank you.
Once more from the audience, maybe from Africa or from Vietnamese or from Indonesia, maybe, please. Okay. Maybe I will present. Will like one of the questioner is okay. Well, you are talking about the personalized learning and how to apply it in the learning, but it is very high step to go there, and reflect on Indonesian technology in education is still far from there. As far we applied in pandemic area, the teacher of especially mathematics teacher usually use technology as LMS in their learning management system in their teaching. But you know, in the paper, maybe the student is having their achievement is increased, but when they come back to the real life, then the offline learning, teacher actually have problems when the student comes, and students, many of them cannot count correctly. They are not having problem in online learning, but when they come in the real life, on the real learning, they actually have many problems, like we don't, and we cannot assess it in the online learning. What do you think about this issue?
Yeah, this is what is the reason why I show you these two figures with the learning gap. That it's a problem in all around the world, not just in Indonesian, or not just in Asian, but even in Europe, that the learning gap is huge as a result of this COVID. And what I've showed you, it's not the difference between the achievement of low SAS students and high SAS students, but the difference between the low SAS students' earlier achievement to their now achievement. So it's really huge, and we should have those students who have this accumulated learning gap to come up with all these materials, at least at those areas which is inevitable for further learning. So mathematics and reading and this learning, it's very important. And that's the point where technology can help us, because if we are able to produce such game-based learning materials which help our students to catch up their learning gap in these fields, then we are on a better way. But otherwise, we will have really big troubles in 10, 15 years when the kids grow up and then they started to leave elementary without knowing how to count or how to read. So it will. I'm pretty sure that if we don't do anything with this generation, with those kids who have this learning gap, that we will face really huge problems in the future. So somehow we should solve this, and technology it's just a tool. It's just the possibilities. It is not just the only possibility. It's just a possibility, but to be able to train them efficiently, of course, first we should know how developed they are in the field of mathematics, in the field of reading. So we need tests. We need to test them first.
Okay, thank you for your answer. Well, for the last chance, any other comment or questions from the audience? Okay, I think maybe they will ask in the other way. Maybe they have a lot of thought, but maybe they have afraid or to cannot speak very well. Maybe they will save it for maybe in the written form, maybe. Okay, before I think, ladies and gentlemen, we have finally come to the end of the part of the session. Before I close this session, I would like to invite Professor Molnar to give us some short closing remarks. Please, Professor, for the closing remarks.
Yeah, thank you for this really kind invitation. And I would say the key takeaway is that we should really love our kids. We should try to teach them what they are prepared for, and not teaching them second grade, third grade materials without being or without knowing that they are ready for all these materials. So it's very important
Alhamdulillah.
To go further and continue their learning. It's really a big challenge for our teachers at every level of the educational system. So I wish all of you a huge power and endurance to realize this and fight with this extraordinary situation.
Okay. Before I close, will you share your material today to us?
Yes, of course, I can send you.
Okay.
Yeah.
Thank you. And finally, ladies and gentlemen, I would like to thank for the speaker, Professor Chanswir Molnar, for the informative and interesting presentation. Also for the participation for their active participation. Please give applause for the speakers and for you all.
Thank you.
That's all for this session. This is the second session after this morning. So this is the second session. For the next session, for this session, Muhammad Waluyo, as the moderator, will close the sessions. Thanks for your attention. Thank you so much. Good afternoon and good morning for the Hungarian time. Assalamualaikum warahmatullahi wabarakatuh. I give the time to the master of ceremony.
All right, thank you, Professor Jong Jafir Molnar, DSc PhD, and Bapak Muhammad Waluyo, SPD, MSc. Good afternoon, ladies and gentlemen. Moving on to the next agenda. So before I close this conference, we will have a photo session that will be captured by the committee. To all participants, please turn on your camera. All right, so there are 4 slides, and I will do the counting per slide. I'm going to start with the first slide. 1, 2, 3. Moving on to the next slide. 1, 2, 3. The third slide. 1, 2, 3. And the last one. 1, 2, 3. All right, thank you very much. Happy audience. Once again, I would like to remind all participants to fill in the attendance list through the link that has been sent in the chat box. All right, ladies and gentlemen, so we have gone through all of these sessions today. And finally, we come to the end of this conference. So let's close this international conference by reciting Hamdalah together. Alhamdulillahirabbil alamin. I deliver huge thanks to all the speakers and all participants for attending this conference. If there are any mistakes during this conference, my apologies. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.